So power in resistor, inductor and capacitor. So here we have to get the power waveform in the elements. So that is the resistor, inductor and capacitor. So first element is resistor. Here resistor, connect the resistor to a voltage source. So now voltage across the resistor is V of t, and definitely current is there in the circuit. So I of t is the current in the resistor. So V of t is the voltage in the resistor and I of t is the current in the resistor. So if you apply voltage source, so KVL in the loop, so minus V of t plus R into I of t equal to 0, V of t equal to R into I of t. So taking this as equation 1, so let I of t equal to, so I am taking current as a sinusoidal signal which starts at origin. So I of t equal to Im sin omega t. So then what is V of t? V of t equal to R into I of t. So V of t equal to R. So R into I of t. I of t is Im sin omega t. So we get R Im sin omega t. V of t equal to R Im sin omega t. So for R Im I am writing that as Vm. So here in resistor, current in the resistor is Im sin omega t and voltage across the resistor is Vm sin omega t. So power. So instantaneous power is P of t equal to product of instantaneous voltage into instantaneous current. So P of t equal to V of t into I of t. So P of t equal to Vm sin omega t into Im sin omega t. So P of t equal to Vm Im sin square omega t. So Vm Im, so sin square omega t can be written as 1 minus cos 2 omega t by 2. So again this 2 can be written as root 2 into root 2. So finally Vm by root 2 is RMS voltage, Im by root 2 is IRMS. So P of t equal to VRMS IRMS 1 minus cos 2 omega t. So if you take this VRMS IRMS into the bracket, so P of t equal to VRMS IRMS minus VRMS IRMS cos 2 omega t. So when in the resistor, if I of t equal to Im sin omega t, V of t equal to Vm sin omega t and P of t equal to VRMS IRMS minus VRMS IRMS cos 2 omega t. So if we draw all the three waveforms, so these are the three waveforms in the resistor. So that is voltage, current and power. So this is the current waveform and this is the voltage waveform and this is the power waveform. So if voltage and current completes one cycle, power waveform is completing 2 cycles and there is no power. So voltage and currents are sometimes negative and sometimes positive, but power is always positive. So because voltage into current is power, so positive value for voltage and positive value of current is you get positive power, and for negative value of voltage and for negative value of current, so minus of minus is plus, so always power is positive. So always resistor takes power from the source and dissipates that power in the form of a heat. So power, resistor does not give that power, whatever the power taken by the supply lines, does not give back to the source at any case. Always it takes power and that dissipates that power in the form of a heat. And maximum values of the power are 0. So here different values are 0, VRMS, IRMS and 2 VRMS, IRMS. So maximum value of the power taken by the resistor is 2 times of VRMS and IRMS. So here if voltage and current completes one cycle, power in the resistor, power waveform completes 2 cycles. So means frequency of the power in the resistor is 2 times of the twice of the frequency of the voltage or current. So if we solve for average power, P average, so whatever the power waveform we got, if we find average value of that, we get VRMS, IRMS. So average power equal to product of RMS voltage into RMS voltage and RMS current. So the resistor always consumes power and is called the active power in watts. So whatever the average power, the power taken by the resistor is called as active power. So P average is called as active power. Always the resistor consumes power and is called the power consumed by the resistor is active power. So frequency of the power waveform is twice that of either current or voltage. So here frequency of the power waveform. So frequency of the power waveform is twice that of either current or voltage. So similarly, next element is inductor. Power in inductor. So here also we have to take the element and connect the element to a voltage source. Now current flowing in the element is I of t. So finally V of t is the voltage across the inductor, I of t is the current in the inductor. Now so if let here also I of t equal to Im sin omega t. I am taking a current in the inductor as a sinusoidal signal which starts at origin. So I of t equal to Im sin omega t. Then so what is V of t? So V of t equal to L into di of t by dt. If you go on solving that, you get V of t as Vm cos omega t, where Vm is equals to maximum value of the voltage is equals to omega L Im. So maximum value of the current is Im. If Im is the maximum value of the current, maximum value of the voltage across the inductor is omega L Im. So maximum value depends on the maximum value of the current, inductor value and the frequency in radians. So instantaneous power in the inductor is given by voltage. So instantaneous voltage, product of instantaneous voltage and instantaneous current is instantaneous power. So P of t equal to V of t I of t. So substituting equation 1 and 2 in this equation. So for V of t, Vm cos omega t. For I of t, Im sin omega t. So Vm Im. So this so multiplying with 2 and dividing with 2. So Vm Im by 2, 2 sin omega t cos omega t. So this root 2 can be written as root 2 into root 2. So finally Vm by root 2 and Im by root 2. So Vm by root 2 is Vrms and Im by root 2 is Irms. So P of t equal to Vrms Irms. 2 sin omega t cos omega t is sin 2 omega t. So finally expression for the power in the inductor is Vrms Irms sin 2 omega t. So if I of t is the current expression, Im sin omega t, V of t equal to Vm cos omega t and P of t equal to Vrms Irms sin 2 omega t. So take these three equations. So if you draw all these three equations in the form of a waveform, so you get waveforms like this. So current is a pure sinusoidal signal which starts at origin. This is the current waveform and this is the voltage waveform. V of t equal to Vm cos omega t. It is a cos waveform. Current is a sine waveform and power waveform. So this is the power waveform. So this is the power waveform in the inductor. So here also, and the mathematical expression for P of t is Vrms Irms sin 2 omega t. So here also, if voltage or current completes one cycle, power waveform is completing 2 cycles. So this is one cycle and this is one cycle. So current is completing one cycle and power in the inductor is completing 2 cycles. So here also frequency of the power waveform is twice the frequency of the current or voltages. So here average power is 0. So here positive area, if you take any cycle, positive area of the power is equals to negative area of the power. So here average power is 0, means net power consumed by the inductor is 0. So it is not consuming the power. So there is instantaneous power, but the net power consumed by the inductor in one cycle is 0. During positive area, when the power is positive means inductor is consuming power from the voltage source. Negative power means so whatever the power taken by the inductor is given back to the source again. So during one cycle of the power, it takes power from the source and it gives power, it gives the same power, whatever the power taken by the inductor, again back to the source. So that's why net power taken consumed by the inductor is 0. So here maximum power is Vrms Irms. So maximum power. So in the power waveform, maximum value is Vrms Irms. So the average power P average is 0 because the average value of sin 2 omega t is 0 over a period. The inductor does not consume any power. So that's why the inductor does not consume any power. So net power is 0. So the frequency of power waveform is twice that of current or voltage. So the frequency of power waveform is twice that of current or voltage. So whenever current, so if you observe this, so whenever during current is increasing, so magnetic field is increasing. So inductor stores energy in the magnetic field and capacitor stores energy in the electrical field. So as current is increasing, magnetic field is increasing. So as magnetic field is increasing, so capacity to store the power is increasing in the inductor. So that's why power is positive during first quarter of the current. During next quarter of this current, as current is decreasing, so it collapses the magnetic field. So that's why whatever the power stored in the inductor is given back to the source, because it has no capacity to store the power. So whenever current is increasing in the first quarter cycle, the magnetic field is built up in the inductance. So and energy is taken from the source and stores in the magnetic field, making the power positive. So when the current is decreasing in the second quarter cycle, the magnetic field collapses and the energy is given back to the source, making the power negative. So the average over one cycle is thus 0. So whatever the power is drawn from the source is given back to the source. The amplitude, or otherwise called as maximum value, so that is Vrms Irms of power waveform, is called reactive power. So here that maximum value is called as reactive power and is measured in volt ampere reactive, or otherwise VAR, or otherwise VARS. So it is represented by Q. So Q is equals to Vrms Irms. That is the maximum power of the power waveform. So the power taken by the inductor is the reactive power, so which is denoted with Q. Q equal to Vrms Irms. So similarly, next element is capacitor. So power in capacitor, so capital C. So again take the capacitor, connect the capacitor to a voltage source V of t. So current in the capacitor is I of t. So basic relation between voltage and current in the capacitor is I of t equal to C dV of t, V of t by dt. So here I am taking voltage as a reference. So V of t equal to Vm sin omega t. Then I of t becomes Im cos omega t, where Im equal to omega c Vm. So here this is the voltage waveform across the capacitor, and this is the current. So voltage is a sinusoidal waveform and current is a cos waveform. So instantaneous power in the capacitor is given by product of instantaneous voltage and instantaneous current. So P of t equal to V of t into I of t. So V of t is Vm sin omega t and I of t is Im cos omega t. So finally you get Vm Im sin omega t cos omega t. So P of t equal to Vrms Irms sin 2 omega t. So here current is voltage is a sine waveform and current is a cos waveform. So voltage is V of t equal to Vm sin omega t. So current is I of t equal to Im cos omega t. And power waveform is in the of the capacitor is P of t equal to Pm sin 2 omega t, where Pm equal to Vrms Irms. So here also power waveform. So if voltage completes one cycle or current completes one cycle, power in the capacitor completes two cycles. So this is the voltage waveform. It is completing one cycle, whereas power is completing two cycles. This is one cycle and this is one cycle. So here voltage completes one cycle and power is completing two cycles. So this is one cycle and this is one cycle. So here voltage or current completes one cycle, power waveform is completing two cycles. So frequency of the power waveform is 2 times the frequency of the voltage waveform or current waveform. So here during this cycle, during this positive half cycle, so capacitor is taking power from the source, and during this negative half cycle, so whatever the power taken by the capacitor is given back to the source again. So similarly it is doing the same here. So it is taking power from the source and it is giving back the power. So in one cycle of the voltage or current, so capacitor takes power from the source and gives back the same power, takes the power from the source and gives back the same power. So here net power is 0 because the positive area is equals to negative area. So net power taken by the capacitor is 0. So during increase of the voltage, so always capacitor stores energy in the electrical field. So as voltage is increasing, electrical field is increasing. So it has the capacity. Capacitor has the capacity to store the energy in the electrical field. So here during this period, first quarter, as voltage is increasing, it has the capacity to increase the electrical field, and that's why it is taking power from the source. So during second quarter, voltage is decreasing. So all the electrical field, electrical field is collapsed here. So that's why whatever the power, whatever the energy stored in the electrical field is given back to the source. So the average power P average is equal to 0 because the average value of sin 2 omega t is 0 over a period. The capacitor does not consume any power. So here the net power taken by the capacitor during one cycle is 0. Positive power equal to negative power. So the capacitor does not consume any power. So the instantaneous power has double the frequency as that of voltage or current. So the instantaneous power, power frequency, power waveform frequency is double the frequency of that of voltage or current. The power is positive when the voltage V is increasing in the first quarter cycle. The capacitor takes power from the source and stores this energy in electrostatic field. So always capacitor stores energy in electrical field, electrostatic field, and inductor stores energy in magnetic field. So when the voltage is decreasing in the next quarter cycle, the electrostatic field collapses and the energy is pumped back to the source. Thus the average power is 0. So the amplitude or maximum value of the power waveform is Vrms Irms and is called the reactive power. That maximum power taken by the capacitor is called as a reactive power and is measured in volt ampere reactive. So unit of that reactive power is volt ampere reactive or VAR or VARS. So it is represented by Q. So Q is equals to Vrms Irms. So that is the maximum power. P max is reactive power. Vrms Irms. So thus the inductor and capacitor are only energy storing elements and do not consume any active power. So active power is taken by only resistor. So inductor and capacitor are not consuming any active power. So the elements L and C are called reactive elements. When a purely reactive circuit is supplied with a sinusoidal signal, no useful power is given by the source, but it must have the capacity to supply power so that energy can be stored and retrieved from the reactive elements. So when a purely reactive circuit is supplied, that is inductor and capacitors are there in the circuit. So at that time, no useful power is given by the source, but it must have the capacity to supply power so that energy can be stored and retrieved from the reactive elements. So this is about power waveforms in resistor, inductor and capacitor.